Welcome to this presentation brought to you by Astronics Test Systems and the Freedom brand of communication systems analyzers. I would like to thank our partner at EPCOM for helping us arrange this meeting with you today. Today's topic is focused on how to test NXDN and dPMR technology radios. All the phone lines are in mute, and if you have any questions, you can please write them down on the right-hand side of your screen under the label called chat. At the end of the presentation, we will try to answer some of your questions. We're also including a few PDF application notes for NXDN radio testing, duplexer, and combiner tuning. These documents can be found on the right-hand side of the screen under the handout sections. At the end of the presentation, you will also receive a copy of the recording for this training. This presentation is divided into two parts. During the first part, we're going to give theoretical talk about NXDN and dPMR technology. Second, we're going to perform a couple of live tests using NXDN radios. We're going to connect to an R8100 communication systems analyzer in Sao Paulo, Brazil, using an ICOM radio. And then I will perform a Kenwood test with my unit here in Florida. Let me introduce you to the people that will be doing the presentation today. First, I would like to introduce you to my colleague, Jose Julio. I call him JJ. JJ is an electrical engineer, an MBA specialized in project management. JJ is based in Sao Paulo, Brazil, and he's responsible for sales and technical support throughout Latin America. JJ has 25 years of experience in the wireless telecommunications industry, and during the last 10 years, JJ has worked with some of the largest LMR companies in Latin America, including Motorola Solutions, Harris, Tate, and ICOM. I'm Luis Riano, and I will be the presenter for the first part of this presentation today. You can also see our email addresses at the bottom. If you have any questions at the end, you can send us an email directly or through EPCOM if you want to. What kind of skills can you expect to gain from this presentation? During this presentation, we will touch on the following subjects. We will give an overview of the history of NXDN and dPMR digital technology. We will give an overview of the AMBI vocoder conversion of analog to digital speech. We'll talk about some key measurements and their limit values. And last but not least, how to configure the Freedom R8000 or R8100 series communication systems analyzer using NXDN and dPMR options. How is this presentation structured? First, you will hear about a customer who used his skills to test a portable NXDN radio in digital mode using his radio test kit. Next, we will go over the basics of the NXDN and dPMR radio systems, and we'll take a quick look at the digital protocol that makes it possible. Finally, we will explain how to quickly and simply configure your Freedom test set to perform transmission and reception tests in NXDN or dPMR digital mode. Could these skills help you save time and money at your company? That's exactly what happened to Mike at a construction company in Canada. One of the subscribers was not able to reach the supervisor on the emergency channel during a routine radio test. This user's health and safety were at risk until the issue was resolved. Mike needed to find the problem and fix it quickly. Using his Freedom R8100 analyzer, he tested the NXDN signal being transmitted by the radio on the emergency channel. He discovered that the radio's programming was not correct because the RAN code for the channel had been inadvertently mistyped. He was able to reprogram the radio and get the user back online in a matter of minutes. He was pleased that his test equipment could provide insight on the digital performance of the radio. Without this capability, Mike would have spent a lot of time testing the radio's hardware and finally driving to the site to identify the source of the problem. Mike's understanding of the NXDN radio system and his test equipment helped him analyze and respond to the situation in record time. Why is it necessary to test radios or subscribers on the network? That's a very important subject and something that for all network technicians and systems engineers is a very important question to ask. Now, if we ask ourselves that question here in this presentation, the answer can be divided into three main points. We need to test these radios primarily because, number one, we need to ensure periodic preventive maintenance of the radio fleet. Number two, because we need to maintain optimal performance of the network. And number Three, because the third area is because we need to control any possibility of interference in the network. Finally, of course, we need to guarantee that the user has good operation of the radio even in marginal conditions. What is NXDN and how does it work? The NXDN standard was developed through the NXDN forum, which was a joint effort initiated by Kenwood and ICOM and hosted by other manufacturers in the industry. Eventually, the forum and the dPMR Association teamed up to develop the available narrowband capabilities. The latest developments include radio trunking type C and D. Type C trunking has dedicated control channels, while type D trunking uses an in-band signaling instead of using a dedicated control channel. Type C trunking mode is the subject of a dedicated video that we're planning to launch during the next couple of months. On this slide, you will see some of the key technical specifications for NXDN. NXDN employs a frequency division multiple access or FDMA architecture and a 4-level 4FSK digital frequency shift modulation scheme. There are two data rates of 96 baud in wideband channels and 4800 baud in narrowband channels. dPMR uses 4800 narrowband baud only. The AMBI plus 2 vocoder is employed for digital voice at full rates and half rate for wide and narrow bandwidth channels respectively. In order to enable secure communications, the standard contains a built-in digital encryption mode, although it is also available and we can also use AES or DES encryption if needed. NXDN uses channel spacing of 12.5 kilohertz, which is called wideband, or in 6.25 or 6.25 kilohertz for narrowband. In the case of dPMR, it only uses 6.25 kilohertz narrowband. And in Europe, for example, the dPMR 446 uses a 400 megahertz space from 446 megahertz to 446.2, which is an unlicensed band for public use of NXDN walkie-talkies. The only caveat there is that the RF power is limited to only 0.5 watts. The NXDN standard defines 3 modes of operation. Mode 1 allows local communications between users without repeaters or infrastructure. Mode 2 extends the range to a single site or to multiple interconnected sites using a single channel through the use of repeaters and other infrastructure, such as IP interconnects. Mode 3 implements complete multi-channel and multi-site trunk radio networks. This mode is outside the scope of this presentation, Mode 3, and we will invite you to this presentation later on, which we're going to schedule for the next couple of months. In this presentation, we will focus on the 2 conventional modes of operation. On the left-hand side of the screen, you can see a diagram of Mode 1. In Mode 1, portable and mobile radios communicate directly with each other through a single transmission and reception frequency. It is known as simplex operation or talk-around, point-to-point. The signal from one user is received by others within a certain limit distance. On the right-hand side of the screen, you can see Mode 2. In Mode 2, you have portable and mobile radios that use frequency pair. They transmit on this frequency received by the repeater and simultaneously retransmitted on another frequency. It can be received by anyone who is in extended range of the repeater tower. All users in the system use the same pair of frequency to communicate. The communication range is extended by linking multiple repeaters to cover larger geographical areas and connecting 2 sites through internet IP addresses or private data networks. When the user transmits, the signal is repeated to all sites, potentially to even cover different parts of the world. Each site can have its own single frequency pair, although when the repeaters are linked, all pairs use them simultaneously for a conversation. The NXDN and dPMR protocols encode digital information by modulating an RF signal in such a way that the data is extracted from the signal at the receiving end. NXDN and dPMR operate under the digital frequency hopping modulation scheme 4-level frequency shift keying, or 4FSK, which means that the radio changes the frequency of the carrier, of the RF carrier. The frequency change, as you can see here on the screen on the top side, the frequency change occurs above or below the center frequency, and the change occurs in 2 different measures. On the screen, you can see that the size of the change depends on the bandwidth available on that channel. If the channel is a wideband channel, or 12.5 kilohertz wide, the signal changes between 2400 hertz and 800 hertz above and below the center frequency. Now, if you look at the image below the screen, on the screen, if the channel is narrowband or 6.25 kilohertz wide, the signal changes between 1050 hertz and 350 hertz above and below the center frequency. Keep in mind that dPMR uses only narrowband channels, so they would only work with the lower band or the narrow band, the 6.25 kilohertz wide. Since the signal has 4 possible values, it can send 2 bits at a time. It's going to send 00, 01, 10, or 11, and after it sends those 2 bits, then it's going to shift the frequency and to send the next 2 bits. So it's going to shift between those 4 different points that we mentioned before. On a wideband channel, you have 9600 bits per second that can be sent, while on a narrowband channel, you can send 4800 bits per second. This is also called bud. How do you convert speech to digital bits and back to speech? On this screen, you can see a block diagram of the transmission from the transmission point to the receiving end. And that's the job of the vocoder is what we're going to talk about in this slide. The vocoder uses a complex algorithm that breaks down the human voice using an ingenious model of human speech. The first part of the process, as you can see on the block diagram, the first part of the process is analog to digital conversion, which turns the voltage levels into their digital values. Next, the digital data is compressed using a proprietary AMBI +2 vocoder developed by DVSI, Digital Voice Systems, and forward error correction bits are then applied so that the data can be perfectly recovered even with a few bit errors in the process. The resulting bit stream is then applied to the 4FSK modulator and transmitted. On the receiving end, the received signals operate in reverse and convert the digital signal back into analog speech. If the radios are being used to send digital data instead of voice, the vocoder is bypassed, and the digital data is passed directly to the modulator and recovered directly by the demodulator. There are 2 versions of the vocoder. We have the full rate vocoder, which is used in wideband channels and uses 7200 bits per second. That basically means that with less compression, that you have better audio quality. And on half-rate vocoders, you use narrowband channels and it uses 3600 bits per second. In this case, more compression means reduced voice quality, reduced audio quality. How can the communication be kept secure from eavesdropping in these cases with this technology? NXDN and dPMR standards include several mechanisms to encrypt and decrypt the data being transmitted. NXDN and dPMR protocols have a built-in scrambling capability. This is a basic encryption scheme that is not extremely secure, relatively speaking, but it is there. To provide more robust security, the standard also allows for AES and DES encryption to be used. Keep in mind that with our unit, with the 8100, we have a tool, use the voice loopback function, which regardless of the encryption, you can use to test your voice and also check for sensitivity on the radio. And we're going to present that in the next few slides when we do a demo. The NXDN and dPMR technology also include advanced functionalities such as those already mentioned and others that you can see on this screen. These features are beyond the scope of this presentation, but if you want to get more detailed information, you can find information online when you look for the documentation related to the standards for NXDN. But among some of the calling modes that we can have with NXDN, you can have point-to-point, radio-to-radio, or dispatcher-to-radio. We can have different user IDs. You can use up to 65,545 different users and group IDs. And you can do emergency calls, man down, and programming over the air. Now the questions are, how can a technician test an NXDN or dPMR digital radio? And what are the measurements and information to test, align, and diagnose problems with the radios? That's what we're going to talk about next. Now, before we go into the actual demo and we show you how to connect the radios and how to test them, what I want to share with you is basically that these are the products that we have in our portfolio. Maybe you already have one or the other in this portfolio. We have from the R8000 A, B, or C to the 8100, the 8600, or the new 8200. All of these units can run the NXDN and dPMR options to do digital testing, and also you can do AutoTune with our units. You have to make sure that you have the latest software release on these units. The software for NXDN started working with after the version 1.7.1. I'm going to show you later on how to check your software version, and also you can download the latest software revisions free of charge from our website, and you can find those at freedomcte.com/updates. There you can see a list of all the different software updates that we have. You can upgrade your unit free of charge. There's a document that explains how to install the software. And you have to, if your version is very old, you have to go one step at a time. You can't jump from a very old software revision to the latest one, which is 3.8 in this case. You have to go step by step until you get to 3.8. If you have any questions, of course, you can contact Jose Julio, JJ, myself, and we can help you walk through it. But the main thing that I want to share with you here is that, for example, the 8200, which is a brand new unit, this unit is going to come with a built-in VNA, single port VNA, so you're going to be able to do more accurate measurements when it comes to VSWR, distance to faults, and also you're going to be able to do Smith charts with this unit. So instead of carrying different units to the field, you just have to take one with you, and you'll be able to test radios and do all the maintenance in the field for all your passive components in the network. So without further ado, what I'm going to do here then is transfer the presentation to Jose Julio in Brazil. He's going to test an ICOM radio, and after that, I'll come back and test an NXDN Kenwood radio. Jose Julio, you're now the presenter, so you can share your screen with the people here. Thank you.
Hey, Luis. Let me. Hello. Good morning, everyone. Okay. Good morning, everyone. Let me share my screen right here. Okay. You guys see my screen?
I can see your screen, but I don't see the 8100 yet.
Okay, let me bring the 8100 here. All right, there we go. Okay, right here, I'm using remote front panel software on application that I can see what's happening with the equipment remotely. Okay, I have my equipment here remotely connected on my router here, and I'm using the Wi-Fi on my OFC. Then I can see what's happening and can touch and can see the screens and navigate inside the equipment remotely. So this is an option that you can find out on the web page, as well as you have the option set on your equipment. All right, let me do a very quick information about the screen readings. So the R8100 separated here the screen for 4 zones. One zone is called as RF zone, other one called audio zone, other display zone, and the meter zone. Those zones could be reached by the keyboard on the shortcut you have here. So if you press number 1, you can go to the monitor or the RF zone. You press number 2, you can go to display zone. Number 4, audio zone, and so on. Number 5, power meter zone. And so as soon as you start the equipment, it becomes us analog ones. So we are doing here NXDN test, and you should pass my equipment to test NXDN. How can I do this? I come to the test mode and take the test mode here. You see down below all the standards, all the kind of modulations you can do. Right here, DMR, P25 phase 2, phase 1, trunking, NXDN, the one that we are choosing right here. As soon as you choose NXDN, the audio zone becomes NXDN zone. In the NXDN zone, you can see some parameters important for the modulations. Suppose you receive a radio from the field and wanted to do a quick test and see how the health of this radio, if this have power, if the modulation is okay, as a vocoder is working and things like that. First of all, you should put the radio on the right frequency. You can go directly here to the monitor frequencies. And for this case, I'm using here ICF 1100 from Nikon. It is programming in VHF. Let me put the frequency I have at 149. 149. Let's see here. 190. 190. This is the frequency I'm using for this rig. Actually, I have to check what port I should put the radio to receive the information. Let me see here that I'm using RF in-out port. That's okay. Enter. Okay. As soon as I press the PTT, attach the radio on the interface here. Press the PTT and see on the screen carrier. This is a FTMA signal. Then you see the carrier very quick. But I have to set some parameters that will be using for later. So for instance here, I'm using monitor frequency as 149.190. I should cap this frequency to the generator too, because I'm using the generator frequency to check the radio sensitivity. Then let me copy this frequency. Okay, already copy. And then check on the generator part. You see 149.190. The modulation output power is a negative 50 dBm. Actually, I have to check the generator port is the same one, because this port is a duplex port, and I can transmit and receive through this port as well. Then I'm okay for now. Let me escape from here. Then let's go to the NXDN or audio zone. Remember on the analog ones, number 2, number 4. Then I have this NXDN information. I can use a bit rate for 480 or 4800 or 9600 for each kind of modulation. Okay. If I don't remember, let me see here. Okay. Suppose I have a 9600 and press the PTT. You see, oh, forget about this. Go to monitor, because the monitor, then you see the signal. You see some information on the display. You see the rate is 9600, but you cannot demodulate the RAM code because you have the wrong information here. So let's change here the bit rate for 4800. Enter and press the PTT. Now I have the RAM code as 1. Actually, I have a symbol deviation or about the 1050, around 1050. I have a modulation fidelity 1.1, 1.2%. That's good. But let me see a little bit more things here to show you guys. Select your display, go to reference level. Let me reduce the level here to see the signal in good shape on the screen. About 40, I believe 35 or 40. Okay, 40 is okay, is better. I have 40 here. Okay, I just changed the level to 40 dB back to see the whole signal on the screen. Okay. Anyway, let me back to the NXDN zone attached by the just type number 4 here. Then I have the information on the display. Okay, for 4800 rate, RAM number 1, symbol deviation 1050, around 1050, modulation fidelity 1.1, 1.2. That's okay. All right, let me see what I can do on this point. I have to copy the RAM code to the generator, you know, because I did some tests later on. We put it here, copy. Monitor test. I can do some monitor tests here. So I can use the 1031 tone to generate a tone such as 1K, 1 kilohertz. Actually, I can use the calibration tones to do some calibration made by the manual. You see the icon on Kenwood manual. You see what can I use this, where I can use those calibration codes. But I can generate those codes to do this kind of calibration. Okay, let me escape from this. Actually, I can do a voice loopback. The voice loopback is a good point to test the vocoder. Remember when Luis mentioned about the vocoder? Vocoder transforms the voice, analog voice, to the digital pulse, and then you can recover this information. So probably if you have a field radio, come and check this possibility for damage or something like that, you can do a test very quick. How can I do this? I go to voice loopback, put it on, and reduce here the, okay, about 50, okay. Then I can use escape, go to voice loopback, voice on, duration, let me put here 10 seconds, and I can press the PTT and speak out loud on the speaker, on the microphone, and check 1, 2, 3, 4, 1, 2, 3, 4, vocoder test, 1, 2, 3, 4, icon, ICF at 1100, 1, 2, 3, 4, 1, 2, 3, 4, test 1, test 2, release the PTT, and 1, 2, 3, 4, icon, ICF at 1100, 1, 2, 3, 4, 1, 2, 3, 4, test 1, test 2. Okay. What do you have here? You check the all path through the analog modulation, or your voice pass through the vocoder, transmit to my R8100, recorded this information and send back the package back to the radio, and demodule this on analog voice, and then you can hear and you can hear what the modulation are. So this is a good test and very quick point. Let me come back from here. Voice loopback off. I don't need this for now. Escape. Okay. Then I check. I could check the RAM. I could check the vocoder. I could check the rate, bit rate for this rig, and everything else in about 10 minutes. Let me do another test here, very quick. Let's pass to the generator. Generate. I will generate a fuse, or I will generate a code here. Let's go to NXDN. Okay. Go to modulation mode. I can put the modulation continuous, and then you can hear 1 kilohertz tone on the speaker. What does it mean? It means that my R8100 are transmitting the frequency, are transmitting the tone, 1031 tone, the digital tone, and pass through, and you're receiving this information. So back to the generator right here. Output level, reduce the output level for about 10, 100, neg 100, neg 110, neg 120. Reduce a little bit more as soon as you put the information. So this is around the sensitivity. 124, 125, 126, 127. Yeah, when I have 127, you see that the signal gone and the sensitivity is around 3 or 4 dB below this. Above this, I'm sorry, let me put here for, yeah, 120 is okay, enter. Let me remove this and do other quick tests for this information. Modulation mode off. Monitor. Let me do the voice loop back with this amount of signal here. Remember, I have 120, negative 120. Let me do the modulation mode, put on monitor. I do the voice loop back when this signal open, put on, okay. And start 1, 2, 3, 4, 1, 2, 3, 4, test, negative 120, transmitting from R8100, test 1, 2, 3, 4, test 1, 2, 3, 4, and see. 4 test, negative 120, negative 120, transmitting from R8100, test 1, 2, 3, 4, test 1, 2, 3, 4. Okay, what do we see here? The sensitivity around 120, and you can transmit and record the information without any distortion, without any missing package and anything else, with this good way to do sensitivity tests on the radio. Okay, all right, let me take a monitor here. Monitor, okay, escape back to the display zone. When I'm in display zone, I have some good points here to see. One of these are bar graphs information. This is a very quick view for the health of the radio. Press the PTT, you see the monitor deviation, frequency error, and power meter. The power meter are showing here in 2 kind of information. So you can see that in dBm, you see 36.9 dBm as well as 4.9 watts down below. So this rig is programming with the 2 power levels. Let me reduce the power level here for low power and press the PTT again. Now I have a 30 dBm and 1 watt. You see that difference and can check and see kind of the power level for this rig, okay? As well as I can go to the eye diagram. The eye diagram, those 4 yellow marks on the screen shows the symbols. The 4 symbols, remember Luis said that the symbols, you have the central frequency, the symbols are shifting in 4 levels. So you have a 10, 15 plus and minus, 30, 150 plus or minus between through the central frequency. So as soon as I press the PTT here, you see the levels, you see the symbols pass through those information, and down below you see the modulation fidelity is around 1.4, 1.5, and so on. So those informations is important to have the equipment. Suppose you receive equipment from the field and do a very quick test and check and select this is good, this is not, or go no go test. You can do this. Press the bar graph again, take the information, okay, take one pen driver, put on the side of the equipment here on the pen driver port, press the PTT, goes to shift and 0. This information appears, you press continue, and then the screenshot we recorded inside the pen driver. You take the pen driver out, open your computer, see the presets here, so shot, and see the latest one. Okay, this information we have for the equipment. Okay, you can use this for a report, or you can use this for something else to show customer, to show your colleagues and things like that. Anyways, let me back to the beginning here. Monitor 1, monitor 2, selective display, spectrum analyzer. Press the PTT, and then you see the carrier on the screen. Okay, Luis, are you back to you right now? So
the presentation that Jose Julio did was very thorough, and what he said was basically he was using the 8100 with the remote front panel. This remote front panel can be used both with the 8100, 8000, or the 8600. All of these different units can use the same combination of the different types of the software. The application for remote front panel is available for all of them. Now, what I wanted to do is basically show you how to test a Kenwood radio, so NXEdge. Before I forget, I also forgot to mention before that with the software updates, which I mentioned, they're free of charge. You can also download the latest software, which will be coming out in a few weeks, couple of weeks. It's going to be version 3.9. That software release, if you already have the options for AutoTune, will allow you to do AutoTune also for NXDN 3000 and 5000. So keep an eye out for our website. Go to freedomcte.com/updates, and then there you will find the new software updates. Okay, so here I have my unit connected here in my office in Florida, and I'm going to try to be a little bit faster with this because I want to show you something else before I finish. So if I'm here and I want to set up, let's say that I have this radio and I don't know exactly what frequency this radio is transmitting. Let's say you receive a batch of radios and for some reason you don't know exactly how they're configured, but maybe you have an idea of maybe this is a UHF radio, and so you can go here to press number 5 on the display. You can go down to power meter, the meter zone. You can select RF scan. And let's say in this case, you could sweep the whole spectrum from 100 megahertz all the way to 1 gigahertz. I mean, these units can go up to 3 gigahertz. So you could scan the whole spectrum. But in this case, for example, we know that this unit is transmitting in 900, in the 900 band. So I put it 900 to 950. That will be the stop frequency. And I'm going to do a single scan. So when I do that, I can scan the spectrum, and the unit automatically recognizes that I'm transmitting, or my radio is programmed at 935.025 megahertz. So now that I know that information, I can go to the RF zone, copy that to my generator. But I want you to keep an eye on something here. If you notice, the rate is at 4800, and I'm not decoding the RAN. If you were to go into the display zone, you would also see that I can't see the eye diagram is all scrambled, and that's because in this case I'm not decoding the RAN, and I don't know exactly how that radio is transmitting, so it's all gibberish. So in this case, for me to be able to fix this, I would have to go into the NXDN zone, go to the bit rate, and then change it from 4800 to 9600 bits, and then now you can see that the radio is actually, you can decode the eye diagram, you can see the RAN, you can see the measurements all together, and so it works better that way. You can perform all the same tests that Jose Julio or JJ was doing a few minutes ago, but I just wanted to show you that very quickly because I think that's very important. So RF scan can save you a few headaches if you pay attention to that. And the same thing, you know, if I were to do the audio loop back, that would do the same thing for me. Also, with I wanted to show you, if you go into settings or into test, and you go into test mode, you have the different test modes here, like Jose Julio was showing you before. You have even Tetra base station, DMO, Tetra TMO, P25 phase 2, and we also have positive train control and avionics. We can do avionics testing just in case if you needed that down the road. Just wanted to let you know. Now, if I go into AutoTune, now I can hear, for example, get here and select the radio that I want to test. So, for example, if I go into, I'm going to test the NXDN portable, right? The first thing that it's going to do is tell me how to configure and how to connect the radio to the analyzer. Once I have that set up and the power supply is set up, I can select if I want to do test only or test in a line. As you can see, when you do test in a line, you have more things that you need to evaluate. This test can take approximately 15 minutes to complete. But once you're done with the test, you can go into tools and then you can look at the test report. This is just an example of a test report. It's a CSV file that you can extract through the USB. Let's say, for example, if I connect a USB over here, you're going to see that the menu changes very fast. You know, you're going to see some new options pop up over here. So you can export, like you can export all the test reports. So you can export this one test report. This is a CSV file that you can print in Excel or Word map, or you can just basically use it so you can send it to your customer and tell them, hey, this radio passed and everything is working fine with that radio. So I just wanted to show you that real quick. If I go into settings here in options, here's where you have all the options for this unit. You can enable new options. When you buy the options, we'll send you a 16-digit key that you can enter here to enable the options that you need. In this case, this remote front panel is one of the options that I'm using right here, but you have all these other options for the unit. Now, if I go back to About, hold on, let me go back here. About, this is where I see the software version that I have on this unit. I'm running the latest version, 3.8, and so that's very important as well. Now, before I forget or before I run out of time, I also wanted to show you, and remind you, there are 5 handouts. Go to the right-hand side of your screen, and you're going to see an area called handouts, and it says 505. There are 5 documents that you can download directly from our website or from this for this presentation, and these are handouts that are application notes that will help you with your testing in your lab. Now let me go back to I wanted to show you something else. A lot of times you guys need to do field testing, and sometimes you have to go out in the field and you need to maybe tune a duplexer. Okay, so how do you tune a duplexer in this case? My best bet, is that you probably have different tools that you use in the field, and I would say that's fine with what you're trying to accomplish in the field. But a lot of times, you can also use this unit. If you have an 8100 and you have the tracking generator enabled, the only thing you need to do is stage your unit. Right now I have a pass and reject duplexer here. And what I'm going to do is I'm going to configure the unit, and I'm going to show you how easy it is. In just a matter of minutes, you can have these measurements done. Please also remember, if you want to have a separate meeting with us to talk more about different issues or to go in depth, please let us know. Get in contact with your representative from EPCOM, and we can arrange that directly with you guys. Now, let me see. If I go here into instruments, I'm going to go into tracking generator. This is the first thing that I see here. This frequency, the center frequency for this duplex that I have here is 452.525 megahertz. I'm going to go here into number of points. I'm going to select 301. Usually you can go up to 600 points. And with resolution bandwidth, I'm going to select narrow. Market mode, I'm going to use delta. And let me go back to, we go to the next one and select the type of marker or marker type. I'm going to put vertical bars. And let me change the output level down to 0 dBm. And I'm going to increase attenuation to maybe 26 dBs. Now I can see the signal a little bit better. And what I'm going to do now is normalize the measurement. Okay, so I'm going to normalize this. What I'm going to do is I'm going to connect a little barrel between the cables that I have connected to the low pass and to the antenna. So it's going to zero out the measurement that I'm trying to get over here, right? So once I normalize it, I'm going to go into this menu here, and I'm going to hit on. Now it's normalized, it's at 0. So now I can go back and reconnect these two cables, one in the antenna port and then the other one in the low pass. Okay, and what I'm going to do is I'm going to go back here to my markers, and I'm going to select marker 1, and I'm going to put here select frequency. I'm going to put here 455.025. Okay, so it's at the bottom in the reject part, and then I'm going to find with marker number 2. I'm going to set the frequency to 450.025. Okay, so here we can see very quickly that we have an insertion loss of minus 1.6 dBm. I'm sure you could do a little bit better, and you guys are professionals at this. You guys do it every day, and you could probably tune this a little bit better. But you can very quickly see on the screen how this, if this duplexer is tuned properly, and make adjustments as needed. Every time you change any frequencies, you're going to have to re-normalize the measurement because your readings are going to change. Now, but for example, as Jose Julio was saying before, let's say that, for example, you send me to do maintenance on a new site, or let's say you're going to launch a new, commission a new base station, and you want to make sure that everything is working fine because you need to supply a report to your boss or to the customer. So you could go there, and then while you're doing the installation, once you have everything tuned, you can hit Shift 0 on the keypad. You get this message, and then you can hit continue, and that's going to send the screenshot to a folder called Freedom /screenshots. So now I could remove that, and if I bring it over here to my laptop, and what I'm trying to do here is just show you that you can use this for different things. Maybe you want to print a report, or maybe you want to use it for future reference. So next time you send someone to do maintenance in 6 months or 3 months from now, they can look at the screenshot and see if there's been any deviation from the original measurements. So that could be very useful. So here's the screenshot of what I just read, or from the unit, and I think this could be a very useful tool when you do, in case you have an audit, or in case you have to report to somebody in country, for example. Going back to the application notes, I think you guys can use a lot of these information if you want. There's a lot of information here that in our library. You can go to freedomct.com/library to download this information directly. We have information for different technologies, and also, let me go back here. We also have for AutoTune for Kenwood radios. This is the 8200 that I was mentioning before to you guys in the presentation. The 8200 just came out. And one of the things that I don't know if you noticed, but is that our units are very user-friendly. They're very intuitive, very easy to use. If you get used to the menus, it's very easy to go from one thing to another. And a lot of times you can save those presets and share them with all the units that you have in your network, so that everybody can be using the same and doing the same testing that you need to perform. On behalf of Freedom and Astronics Test Systems, we trust that you have found this presentation useful, and we hope that you will reach out to us, let us know how we can help you better and with our expertise and experience, and we can save you time and money as you endeavor to keep up and maintain your radio communications flowing.